So, let's go. Let's look at one of those concepts that can really mess with your head. A light year sounds like a unit of time because of the name, but it actually describes the massive physical gap between stars. It is a distance so large it is almost impossible for our brains to even picture. A light year is the total distance light travels in 1 year. Light moves at 186,000 miles every single second. To put that in perspective, in 1 second, light could circle the entire Earth 7.5 times. That speed is already difficult to visualize. Now imagine light maintaining that pace for an entire year. That's 365 days of travel, adding up to roughly 31 million seconds. At 186,000 miles every second, the total distance comes out to about 5.88 trillion miles. That is just one light year. To see how lonely our corner of space is, we can look at our closest neighbor besides the Sun, Proxima Centauri. It sits 4.24 light-years away. If you multiply that 5.88 trillion by 4, you're looking at over 24 trillion miles, just to reach the very nearest star in this cosmic wasteland. Our fastest technology today, the Parker Solar Probe, moves at 430,000 miles per hour. Even at that speed, a trip to that nearest star would take over 6,000 years. No human lifespan could cover that distance. Your kids and 100 generations of their descendants wouldn't make it. We aren't even talking about the other side of the galaxy, just the star next door, and it is effectively unreachable. Think of a light year as a cosmic wall, a physical limit that keeps us isolated in our own tiny corner of space. The distances are so massive that they create a boundary we can likely never cross. When you look up at night, you are seeing a version of the universe that existed in the past. Because light takes time to travel across the void, some of those stars you see tonight might have actually burned out or collapsed long ago. We can see this delay even with our own sun. It takes 8 minutes for sunlight to reach Earth. If the sun were to suddenly go dark, you would continue to see it shining in the sky for 8 more minutes. You'd go about your day with no warning at all, until that last bit of light finally arrived. Other stars are much further away, which means the delay is much longer. The bright star Sirius appears to us as it was over 8 years ago. The red giant Betelgeuse is 550 light-years away, so the light hitting your eyes tonight has been traveling since the year 1474. If that star exploded 5 centuries ago, the news hasn't reached us yet. We are still waiting for the light to deliver the message. Most stars in the sky are hundreds or thousands of light-years away. Many of them are likely already gone, having collapsed into black holes or exploded into supernovas. Their light is still trekking toward us, acting like a delayed signal from an object that might no longer exist. Looking at the night sky is like walking through a gallery of ghosts. You are surrounded by images of things as they used to be, with no way of knowing which ones are still there right now. Right now, you are moving through space at over 1,000,000 miles per hour. The Earth orbits the Sun at 67,000 miles per hour, while the Sun circles the center of the Milky Way at over 500,000 miles per hour. When you add in the movement of our entire galaxy, you reach a speed that is almost impossible for us to comprehend. You don't feel this movement because everything around you is traveling at the exact same speed. It's like being on a smooth-running train with the windows blacked out. You're hauling through the dark at 1,000,000 miles an hour, but from your perspective, everything seems perfectly still. Even at these incredible speeds, crossing just 1 light-year would still take about 700 years. We are moving faster than any vehicle we've ever built, yet we can't even cover the distance of a single light-year within a human lifetime. In the vast scale of the universe, 1,000,000 miles per hour is practically standing still. Einstein's research showed that this link between speed and time is a physical reality we can actually measure with instruments. He found that the faster you move through space, the slower time passes for you. We see this with astronauts on the International Space Station, who age a tiny fraction of a second slower than people back on Earth. If you could reach the speed of light, time would effectively stop for you. From light's perspective, a trip across the universe is instantaneous. But there is a catch for biological beings like us. Because we have mass, the energy required to move us gets higher the faster we go. Approaching light speed would require more energy than exists in the entire universe. The laws of physics essentially keep us anchored to a slower pace. This creates a massive divide. Light can cross the cosmos without experiencing a single second of the journey, but we are forced to experience every moment of a trip that would take thousands of years. While light can zip across the void, we are bound by time and the slow reality of a human life. Our own home galaxy, the Milky Way, is about 100,000 light-years across. It is so vast that light itself needs a full 100,000 years just to travel from one side to the other. We live in a quiet, suburban corner of this galaxy, called the Orion Spur, about 26,000 light-years away from the busy center. We're essentially in the middle of nowhere. This distance makes communication almost impossible. If we sent a light-speed message to the other side of the galaxy, it would take 100,000 years to arrive. Even an immediate reply would take another 100,000 years to get back. That's a 200,000-year wait for a single hello. Entire civilizations could rise and fall in the time it takes for a message to cross that gap. We might be part of a galaxy filled with life, but the distances are so large that we remain effectively isolated. Even the nearest large galaxy to us, Andromeda, is 2.5 million light-years away. It is currently moving toward us at 250,000 miles per hour, and in about 4.5 billion years, our two galaxies will collide. This will eventually tear solar systems apart and fling stars into the empty dark. We can calculate this collision with math, but we are powerless to change it. We can only watch it approach. On the scale of the universe, these massive events happen over billions of years, far beyond the reach of a human life. The universe continues its slow, inevitable movements, largely indifferent to our presence. We are limited by something called the observable universe. This is a boundary about 46 billion light-years away in every direction. It's the limit of how far we can see, simply because the light from any further away hasn't had enough time to reach us since the beginning of time. To make things more difficult, the space between galaxies is expanding, and that expansion is actually picking up speed over time. Some distant galaxies are being pushed away from us so fast that their light will never be able to catch up. They are effectively disappearing behind a horizon we can never reach, no matter how fast we try to travel. Even the stars we see aren't the calm points of light they appear to be. They are violent fusion reactors made of plasma, held together by intense gravity. By the time their light reaches us, it has been stretched and mangled by the long journey through space, changing its appearance before it ever hits your eyes. Despite these hurdles, we still try to reach out. In 1977, we launched Voyager 1, which is now over 14 billion miles away. It is the furthest any human object has ever traveled. On board is the Golden Record, a collection of sights and sounds from Earth, meant to act as a message in a bottle for anyone who might find it. But at its current speed, Voyager won't pass another star for tens of thousands of years. By the time anyone, or anything, could possibly find it, our entire civilization might be a distant memory. We sent this message into the dark, knowing we would never hear a reply, simply because the alternative was to remain silent. There is an invisible force we call dark energy that is pushing the universe apart. It makes up most of the cosmos, and it is causing everything to expand faster and faster. This discovery has changed the way we think about the future of the cosmos. Because of this expansion, distant galaxies are currently being dragged beyond our reach. Eventually, their light will stop arriving entirely. One by one, the lights in the sky will disappear from our view. Trillions of years from now, every galaxy outside our local group will be gone. The sky will be completely black. Any civilizations living then will look up and see an empty void, never knowing that the universe was once filled with billions of other galaxies. Eventually, the stars in our own neighborhood will burn out, matter will decay, and the universe will fall into a state of total darkness and silence that lasts forever. A light year acts as a timer, marking the steady, slow-motion disappearance of everything we can see in the sky. It reminds us that every year that passes, the universe is getting a little emptier. In the end, light years describe our isolation. reminding us how small and temporary we are in a universe that moves on without us. We are travelers on a tiny rock, watching the light from stars that might already be gone. If you want to keep exploring the mysteries of the void, hit that subscribe button. I'll see you in the next one.